Welcome to BIM and AI in Practice, your trusted source for mastering Autodesk Revit with clarity, confidence, and efficiency. We're excited to have you join us for the fourth episode in our Revit 2025 tutorial series. In this session, we'll take a deeper dive into one of the most powerful and often underutilized toolsets in Revit, the Annotate tab. Whether you're preparing detailed construction documents or working to enhance the graphic clarity of your BIM model, the tools within the Annotate tab play a critical role in ensuring accuracy, consistency, and readability throughout your entire design process. Even for experienced users, today's walkthrough will reveal practical strategies to streamline documentation workflows, increase model precision, and foster stronger collaboration across architectural, structural, and MEP disciplines. At BIM and AI in Practice, we're committed to delivering hands-on, actionable content designed for real-world AEC workflows. If you're looking to sharpen your BIM expertise while exploring how artificial intelligence can elevate your design processes, make sure to subscribe and stay tuned for regular updates. Now let's continue by taking a closer look at spot coordinates, a precise annotation tool that allows you to display the X, Y, and Z location of specific points within your model. This feature is particularly valuable for site planning, prefabrication, and interdisciplinary coordination across trades. The core concept is similar to the spot elevation tool we explored in the previous video. However, spot coordinates go a step further by reporting the north, south, and east-west positions of a point in the project. This allows for a more comprehensive understanding of spatial relationships within your BIM environment. In your documentation, you can place spot coordinates on floors, walls, toposolids, and boundary lines. These annotations not only display the coordinate values, but can also include the elevation of the selected point and custom indicator text, offering greater control and context in your views. Spot coordinates can be placed in the same locations as spot elevations. However, what distinguishes them is how they relate to the project's reference points. Coordinates are reported relative to either the survey point or the project base point, depending on the value assigned to the coordinate origin type parameter within the spot coordinate family. How to add a spot coordinate in Revit. Spot coordinates are reported with respect to the shared coordinate system, allowing for precise placement aligned with your project's geolocation or internal reference points. To add a spot coordinate, follow these steps. First, navigate to the Annotate tab, then click Spot Coordinate from the Dimension panel. Next, in the Type selector, choose the specific type of spot coordinate you want to place. If you'd like the elevation to be included, make sure to select the Include Elevation option. Then on the Options bar, choose whether or not to add a leader. If you enable the leader option, you can also select shoulder to include a bend in the leader line for improved visual clarity. After that, hover over the element where you'd like to place the coordinate. You can select an edge of an element or a point on a topo solid. As you move your cursor over valid elements, Revit will display the coordinate values directly in the drawing area, giving you a live preview. Depending on how you want the annotation to appear, if placing without a leader, simply click to place the spot coordinate. If placing with a leader, move the cursor away from the element and click to set the coordinate. If using a leader with a shoulder, move the cursor away, click once to place the shoulder, Then move again and click a second time to place the coordinate itself. To complete the command, press S key twice. Once you've placed a spot coordinate, you can easily adjust its position by selecting it and using the drag controls to move it to a new location. When using a spot coordinate to identify a precise location within the model, it's crucial to understand the relationship between the project base point and the survey point. These reference markers play a foundational role in defining the model's global positioning, ensuring accurate coordination across linked files, shared models, and site-based workflows. Displaying the project base point, survey point, and internal origin in Revit. By default, the project base point and survey point are only visible in the site plan view, while the internal origin is turned off in all views. However, you can manually make these reference points visible in any 2D or 3D view as needed. Keep in mind that for cropped views, you may need to adjust or resize the crop region to reveal these elements. To make these points visible, follow these steps. First, open the view in which you want to display the reference points. Second, go to the View tab, and in the Graphics panel, click Visibility Graphics. You can also access this dialog from the Properties panel when you're in a floor plan view. Next, in the Visibility Graphics Overrides dialog, under the Model Categories tab, scroll down to the Site category and expand it. Finally, check the boxes for the reference points you'd like to display. Select Project Base Point to make the base point visible. Select Survey Point to show the survey marker. Select Internal Origin to reveal the model's origin point. Click OK. Alternatively, if you need a temporary view of these elements, click the Reveal Hidden Elements button on the View control bar. It's the icon that looks like a light bulb. This allows you to see hidden geometry, including reference points, without changing permanent visibility settings. Understanding reference points and orientation in Revit. Let's take a moment to clarify the role of the project base point and the survey point, as well as how these relate to real-world positioning in your Revit model. The project base point appears in views as a small circle with a crosshair. It defines the origin 000 of the project coordinate system. This point is typically used as a reference for internal measurements across the site, ideal for maintaining control over your model's local positioning. In contrast, the survey point is represented by a triangle with a cross inside. It marks a real-world location near your project, such as a site corner or the intersection of two property lines. The survey point defines the origin of the survey coordinate system, providing essential context for aligning your model to global or site-specific coordinates. If you're still getting familiar with Revit's positioning tools, here are 3 additional concepts to keep in mind. Geographic location defines the model's position on Earth using global coordinates, which can impact sun studies and site orientation. True north sets the actual north direction based on your site conditions, which is critical for environmental analysis and orientation accuracy. Project North aligns the building's main axis with the top of the drawing area, simplifying design, drafting, and sheet layout. Understanding how these systems interact is fundamental to accurate site placement. Interdisciplinary coordination and the success of any BIM project. A closer look at the project base point. By default, in Revit stock templates, the project base point identifies the origin 000 of the project coordinate system. It serves as a reference for internal measurements across the site and should be placed in a strategic, convenient location within the model to support consistent, accurate on-site referencing. When a new model is created, the project base point initially aligns with the internal origin, the fixed point from which Revit's internal coordinate system begins. This internal origin underpins the positioning of every element in the model, even though it is usually hidden from view. As part of your project setup, it's essential to determine where to place the project base point. Establishing its location early ensures consistency in measurements and alignment throughout the design and construction process. If you're working as part of a team, collaborate to select a common reference point that suits the entire project's needs. This coordination helps all disciplines, architectural, structural, and MEP, operate from the same spatial reference, avoiding misalignment and simplifying model coordination. Best practices for placing the project base point. The location of the project base point should be practical and project-specific. For example, in a large commercial or institutional project, it's common to place the project base point at the intersection of primary building grid lines. This ensures alignment with structural layouts and simplifies coordination between disciplines. For residential or smaller commercial projects, where grid lines may not be used, you might choose to place the project base point at a corner of the building or another clearly identifiable and consistent location within the model. Once the project base point is defined, you can move it later if necessary. However, it's important to understand that this point can be either clipped or unclipped. When clipped, moving the project base point adjusts the entire coordinate system relative to the model geometry. When unclipped, you can move the project base point independently without shifting the model geometry, useful for alignment without altering the model's internal positioning. Always double-check whether the point is clipped or unclipped based on your coordination intent before making adjustments. Key considerations when working with the project base point. When working with the project base point, keep these important points in mind. 1. Visibility and views. By default, the project base point only appears in the site plan view. However, you can make it visible in other views by following the steps we discussed earlier. 2. It cannot be deleted. You cannot delete the project base point in Revit. It's a critical reference point for your project's coordinate system. 3. Project North and the Y-axis. The Project North orientation defines the Y-axis of the project base point, helping you align the model's geometry with the project's true orientation. 4. Locking the project base point. To prevent the project base point from moving inadvertently, you can pin it in place, select the project base point, and click Pin in the Modify panel. The Pin tool locks a modeling element, preventing accidental shifts. When the point is pinned, tools like Relocate Project will be disabled to maintain the base point's fixed position. If you attempt to move a pinned element, Revit will warn you that the element is locked. A push pin icon will also appear near the point to visually indicate it's pinned. To move the point, you'll need to unlock it by clicking the push pin control. Click the push pin again to relock the point. Modifying spot coordinates relative to the project base point. To report spot coordinates relative to the project base point, modify the spot coordinate type properties, change the coordinate origin parameter, project base point. Coordinates will be reported relative to the project base point origin. Survey point. Coordinates will be reported relative to the survey point origin. Internal origin. Coordinates will be reported relative to the fixed internal origin, the default origin point used within Revit. By adjusting the coordinate origin parameter, you can control how Revit displays coordinates in your model, ensuring the correct reference system is applied for your project's needs. Modifying the appearance of spot coordinates. In addition to adjusting the coordinate origin, you can customize the appearance of spot coordinates to align with your organization's or industry's standards. Leader arrowhead. This option controls the appearance of the leader arrowhead attached to the spot coordinate. If you set the value to none, it will remove the arrowhead entirely, leaving just the coordinate label. The symbol setting changes the look of the symbol that accompanies the spot coordinate. You can adjust the style or choose different symbol heads to match your project's visual preferences or drafting standards. For you to maintain consistency in your documentation and ensure that spot coordinates are displayed according to your specific requirements. Coordinate text and units. Let's now look at how we can modify the appearance of the spot coordinate text to meet your project standards. Text formatting. Italic. Apply italic formatting to the spot coordinate value and associated text. Bold. Apply bold formatting to the spot coordinate value and text for emphasis. Text size. Adjust the size of the elevation text to ensure clarity and legibility. Text. Choose a specific font style for the elevation text to align with your project's documentation style. Text background. You can modify the background for the text. If set to opaque, the text background will cover any objects behind it. With transparent, objects behind the text will remain visible. Primary units. Format. Click the button to open the Format dialog. Clear the Use Project Settings option, and then set the appropriate unit values. We covered this in earlier videos, so you'll already be familiar with the steps. Top coordinate. This setting determines which coordinate value appears on top. For example, use north-south for vertical alignment. Bottom coordinate. This setting determines which coordinate value is placed at the bottom For instance, use east-west for horizontal alignment. Include elevation. This option displays the spot elevation along with the spot coordinates. If your standards require specific labels for the coordinates, you can adjust the north-south indicator and east-west indicator. North-south indicator allows you to specify how the north-south direction is labeled. For example, you might choose to label it as X. East-west indicator allows you to specify how the east-west direction is labeled. For instance, you might label it as Y. Defining the survey point. Next, let's dive into the survey point, a crucial reference for positioning your Revit model within the real world. The survey point represents a known point in the physical world, such as a geodetic survey marker or the intersection of two property lines. It's used to correctly orient your model's geometry within another coordinate system, such as those used by civil engineers or site planners. In Revit, the survey point defines the reference for the survey coordinate system, ensuring that your model is aligned with real-world coordinates. When working with a civil engineer, be sure to request the site coordinates to correctly position the survey point in your model. Aligning the survey point. To define the survey point, first open the site plan view or any other view that displays it. If the project base point and the survey point are located at the same position, hover over the symbol. The tooltip or status bar will display Site Project Base Point. Press Tab until it says Site Survey Point, then click to select the survey point. Once selected, a clip icon will appear next to the survey point, indicating whether it's clipped or unclipped. If the point is clipped, simply click to unclip it. Next, you can drag the survey point to the desired location. Alternatively, you can enter specific values for northing in S, easting EW, and elevation in the Properties palette or directly in the drawing area. Once the survey point is in place, click to clip it again if desired. Pinning the survey point. To prevent the survey point from moving unintentionally, pin it by clicking Pin in the Modify panel. Pinning the survey point will disable the Rotate True North, Acquire Coordinates, and Specify Coordinates tools, ensuring the survey point stays locked. Even after initially defining the coordinates, you can still move the survey point later if necessary. Just ensure it's unlocked before doing so. As we've explored today, tools like Autodesk Revit are more than just drafting programs. They form the backbone of how we digitally conceptualize, develop, and document architectural projects. These features enable us to bridge the gap between creative design and construction reality, making our designs more informed, reliable, and ready for implementation. Thank you for joining us for Part 5 of our Revit 2025 tutorial series. We hope the insights shared today have been both practical and inspiring, and that you're feeling more confident in using these tools for your projects. Be sure to tune in next week as we continue exploring more advanced Revit features, including how they integrate with BIM best practices and emerging AI technologies. Until then, keep designing smarter.